Question 7. Manganese dioxide catalyzes the decomposition of hydrogen peroxide solution. Oxygen and water are produced. 7.1. Explain how a manganese dioxide catalyst increases the rate of decomposition of hydrogen peroxide. A catalyst provides a different pathway for the reaction, which has a lower activation energy. A student investigated the rate of this reaction. This is the method used. 1. Add 50 centimeter cube of 2 mole per decimeter cube hydrogen peroxide solution to a conical flask. 2. Add 1 grams of manganese dioxide to the conical flask. 3. Place the conical flask on a balance and start timer. 4. Record the total mass loss from the conical flask every 20 seconds for 180 seconds. Question 7.2. Explain why the mass of the conical flask and contents decreased. Oxygen is a gas, O2 diatomic gas, which escapes from this flask. So it's the escape of oxygen that reduces the mass. Question 7.3. Figure 4 shows the result of 50 centimeter cube of 2 mole per decimeter cube hydrogen peroxide solution and 1 grams of manganese dioxide. A tangent to the line has been drawn at 75 seconds. It's 75 seconds and the tangent is drawn to that line. Determine the rate of reaction when the time was 75 seconds. Give your answers to 2 significant figures. So we have to go back to the graph and calculate the gradient here. So to do the gradient, we draw this vertical line here, picking these 2 points, point 1 and point 2. And from that point, I know this x, this is x and y coordinate for point 2. This is x and y coordinate for point 1. I can find the height here, that distance here, and I need to find that distance here for the gradient. So what I need to do is then to show how I got my coordinates here and there. First of all, the x coordinate is easy. It's just this point here. So that's the x coordinate. But the y coordinate is this one here. So how do I get that? I got the points here, these 2 points, 1.6 and 1.8. So for y coordinate here, I get 1.8 minus 1.6. So that's the difference in length there, and that's 0.2. So from there to there is 0.2. From there to there is 0.2. But how many little squares are there? So I need to divide it by 1, 2, 3, 4, 5. There are 5 squares there, so I need to divide 0.2 by 5 and get 0.04. So each little square is 0.04 in height. From there to there is 0.04. And so what I then need to do is to count how many squares are here from there to there, and that, if I count the squares, how many from here to there, that would be 11, 12, 13. So 13 times 0.04 is 0.52. So that's 0.52, that length here. But if I want to know what that is, I have to take away 1.8 minus 0.04, because that's just one block away from 1.8. So 1.8 minus 0.04 we give 1.76, is 1.76 here. And the coordinate for this one, we know that each little box here is 0.04. This is 1.2, and if I add 0.04, that would be 1.24 for the y1 here. That's y2. So for x, now the same thing will happen. This is 0 to 25. There are 5 boxes here. So I need to divide 25 by 5. I divide 25 by 5, I get 5. So each little box is 5. And so I can tell that obviously this is 25 here, so that's good. And that too is 100. So this one is much easier. And now I need to calculate the gradient. So I want to come here and calculate the gradient now. And the gradient will be the rate which is y2 minus y1 over x2 minus x1. And my y2 is 1.76 and my y1 is 1.24. And if I divide it by my x, 125 minus 25. My x2 is 125, my x1 is 25. And then I'll get this calculation can also be done there. That's the 13. So that height here will be 13 times 0.04, that length here. And you can see it's going to be happening here as well, 0.52. And 0.52 is this one here, the difference. And 125 minus 25 is 100. If I divide it by each other, I get 0.0025 grams per second. We need two significant figures. So that one significant figure there, one there, so that's 2. You don't count the zeros. So the answer should be 0.0052 grams per second. So that will be the answer. Question 7.4. The result for 50 centimeter cube of 2 mole per decimeter cube hydrogen peroxide solution and 1 gram of manganese dioxide are shown again on figure 5. This is the diagram here. Now the question, and here's the question. The student repeated the investigation using 50 centimeter cube of 1 molar, so half of that, 1 molar of hydrogen peroxide solution and 1 grams of manganese dioxide. Sketch the expected result of 1 mole per decimeter cube hydrogen peroxide solution on figure 5. Well, because it's going to be less now, because we have less concentration, because we're using 1 molar now of hydrogen peroxide rather than 2 molar here. So this was a higher concentration. So you expect that graph to be less. And so it's half of that actually. So we'll be going towards a half here of concentration. So that will be, you draw the curve approaching there.